Well, good afternoon, everyone. My name is Matt Ferrari. Really excited to spend time with each of you today. Today we're going to be talking a lot about cloud analytics and data masking, and hot topic right now, not only because what's going on inside of what the public clouds are investing in and doing, but certainly the circumstances of the world today. So really excited to spend time diving in deeper. In terms of your speakers today, you're listening to one. So my name is Matt Ferrari. I am the co-founder and CTO of ClearDATA. ClearDATA is a 100% healthcare and life science focused organization that focuses on safeguarding PHI and other sensitive data. And so in my role, I have run lots of different parts of our organization, from product management to product development to innovation. But at the end of the day, my role is really around building out the technical strategy around how can we help healthcare and life science organizations advance in the world of the provider, the payer, the pharmaceutical, and the product or the healthcare IT world. And so, been fortunate enough to have been privileged to work with Connor Colgan joining me today, the technical product manager from ClearDATA. Been working with Connor for many years, and Connor's got deep experience as it relates to architecture, both on AWS and in public cloud in general. And Connor today is not only going to wax poetic about some of the real problems in the machine learning space, but also really going to show a live demo of one of the recent launches that ClearDATA has brought into the market. Really excited to talk about today. In terms of an agenda, let's kind of dive in. I will tell you that this webinar is really focused on providing you with an overview of ML services, right? So outcomes that we have seen in the space from organizations like AWS, Google, and Microsoft Azure. It's focusing on addressing challenges and opportunities from gleaning from these large data sets. How can you actually get started in the ML space, and what tools out there have we seen that have really driven impact? We're also going to focus on sharing what ClearDATA is doing to help organizations kind of make the most of these ML and analytics-based tools, while really staying inside of the bounds of regulations, like HIPAA, GDPR, GXP, because look, this is PHI. And then finally, how can we really use predictive modeling to gain better insights? And hopefully, each of you can make this interactive. I would really encourage Q&A. If you've never spoken to me before, I'll tell you now, I love back and forth, so would love to make it possible. At the end, we will have a Q&A session, and both Connor and I would love to answer your questions. So let's really dive in. And the very first thing that I wanted to talk about was just a 30 to 60 day period. Really wanted to talk about some of the ways that three public clouds and healthcare organizations are investing in R&D, kind of to bring machine learning to the masses. And I could have made this a ton of slides, right? This is only June and July of 2019, but there's some really interesting use cases. And so wanted to kind of level set there. You can see here that there's really a focus on improving healthcare and the patient experience by driving outcomes. And so you think about detecting brain cancer with ML before a radiologist can even spot it, or you think about predicting lung cancer from a CT scan, or getting in front of diabetic affliction and helping preserve kind of that vision or postpone that vision loss. And so we have seen a lot of these use cases actually happen. And a lot of that is in part to some of the cloud services that we're going to talk about that the three public clouds have brought to market, and then organizations out there that help make them compliant, secure, private in an ongoing way. Some of the ones that really strike me here are really around developing models around treating chronic disease, from predicting those patient populations that need preemptive care based off of population health and big data initiatives. Historically, many of you in the healthcare field know this has been a challenge because of all of the structured and unstructured data. that lives inside of these environments. Connor and I have a bit of an unfair advantage. We work with hundreds of healthcare and life science customers, so we know that the data can be structured, it can be unstructured, it can live inside of a database, it can live in doctor's notes, it can live in images, it can live in text files. It's really everywhere. And so how do we correlate that data and then use some data modeling tooling to actually gain insights from it has been a real kind of vision for not only ClearDATA, but a real vision that we've heard time and time again for the healthcare industry, and really excited to see that we're starting to see impacts, when you think about really kind of preempting some of these things and amplifying these opportunities across the patient population. So as far as ClearDATA goes, I will tell you that ClearDATA is focused on really protecting healthcare environments inside of the three public clouds, being AWS, Google, and Azure, and leveraging machine learning and AI to let you scale your big data initiatives on the cloud. And so we'll talk about some of those benefits throughout, but just to give you a little background, I will tell you that almost everything we do is PII and PHI. ClearDATA has been steeped in this for many years and is premier partners with these three public cloud providers. The key takeaway I would tell you is almost everything that we do involves sensitive data, whether it's PHI or PII. We've been privileged to work with organizations like AWS, Google, and Microsoft, even under NDA projects, specifically to try to drive ML and AI into these patient populations faster. And so we've been working with these three public clouds for a couple of years on services that they have been brought to market, and then helping those organizations get them to be what's known as HIPAA eligible or compliant to process, store, or transmit PHI. As we think about some of the solutions that ClearDATA has, I would tell you that it's a focus around a combination of software, which takes a look at environments from a compliance perspective inside of the public cloud, identifying deviations from a state of compliance. Let's say it's a encryption issue inside of an S3 bucket, or it is a identity and access management issue where we've given too many privileges to a practitioner who may not understand how to use a HIPAA eligible service. And we've built automation around that, automation to both identify, but also log from an Office of Civil Rights Compliance perspective, and then automatically remediate so that you don't have to understand every single public cloud service and feature as it changes. I'm sure many of you know these changes happen fast and furious, right? Hundreds, if not thousands, of changes across these three public clouds a year. And Connor and I were fortunate enough to be at AWS reInvent just in November to witness it firsthand. And the truth is that between the changes in the state of compliance, when combined with the changes inside of the features inside of the public cloud themselves, and then finally the changes in your healthcare application, the truth is it's a pretty hard job to keep up with. Is everything compliant on an ongoing basis? When you think about change management and ITIL and all the changes that are going to happen inside of your environment, and we could probably do an entire webinar on those. And so ClearDATA focuses on taking those three intersects and building software around that. So we know when there's changes inside of a feature set from Amazon, Google, or Microsoft, how can we actually map those back to a state of compliance? How can we visually show you, red, yellow, green, how compliant am I throughout the life cycle of the PHI in my environment? And when I do something silly, can I be automatically remediated back into that state of compliance? And that's been ClearDATA's focus for a long time. As you can see here on the slide, all of that is backed by managed services. And so while you can subscribe to just software, so that if you have your own public cloud experts, you don't need to in any way validate and pay for managed service personnel on top. ClearDATA also offers a managed service organization, which is 24/7 compliance and security experts that are public cloud certified, that all they do is focus on processing, storing, transmitting PHI in a safe way. And so that is really what ClearDATA does, just to give you the quick and dirty. In terms of the how we're backed and how we actually have started the business, it really all started with us becoming HITRUST. And ClearDATA is HITRUST focused and has been since 2014, continuing to be one of the only exclusive healthcare and life science managed service providers in the space that has focused on HITRUST. We have expertise in GXP and GDPR as well as HIPAA, and we are steeped in ITIL. We oftentimes work with healthcare organizations that are working with machine learning models and even other infrastructure models to keep them compliant throughout the life cycle. So we're joining their CAB or their change advisory board process, and in many cases, from a managed services perspective, really helping them execute from there. On the right-hand side, I mentioned earlier, we are premier partners both with Google and with AWS, and we're Microsoft Gold partners as well. And so we spend an enormous amount of time with these cloud partners talking to them about how can we also do our part to advance healthcare, how can we do our part from a machine learning perspective to really drive data insights rather than just a whole bunch of storage. And so that has been ClearDATA's value from a compliance and a partnership perspective. Diving now into analytics, which is really where I wanted to focus a lot of our time, I would tell you that from an analytics perspective, the possibilities inside of the public cloud, without sounding like a commercial, is just absolutely overwhelming and increasing all the time. And you can see Dale from Toward Data Science here, stating that when it comes to how machine learning might benefit humanity, there's almost no field more promising than healthcare. And I'm going to divert from my normal, kind of webinar and tell you, even this week, right? State of the world. Even this week, one of my friends that is, a data scientist leading the way at an organization called Closed Loop AI, actually released the COVID-19 vulnerability index, right? So you think about that. You think about how that can affect the world from an ML and AI perspective. And so let's talk about it, right? That's an open source index. That's AI-based predictive model that identifies people like you and me who have a heightened vulnerability to complications if they were to get, COVID-19, right? And it's intended to help hospitals, federal, state, public agencies, and it's free, right? And it's all thanks to some of the machine learning models that we're going to talk about today. It's open source. You can download the Python libraries, and it's HIPAA compliant. And so that's just one example of what organizations like, Closed Loop and others are actually doing in the space from a possibility perspective, and they're doing it on a whim, right? They're doing, this is a pandemic that is exploding in our world, and they were able to leverage public cloud services and their ML AI expertise to get this out into the market just that fast. And so that's really where I want to focus a lot of our conversation today. From a AWS perspective, let's start there. I wanted to talk a lot about some of the services that I've seen healthcare organizations like yourselves adopt and what they're doing with them. And then we're gonna dovetail into a demo that Connor can show what we're doing. And so really wanted to start out with SageMaker. And when I think about SageMaker, I think about, wow, you don't have to be a data scientist to learn. I've spent a lot of time with large healthcare organizations that one of their struggles is actually we can't hire enough ML data scientists to actually run our models. That was a real conversation that I had on site just a couple of weeks ago. And the truth is that organizations like AWS have built tools like SageMaker to really focus on building and deploying machine learning models fast, where you don't have to be a data scientist. It's almost drag and drop style, and you bring machine learning to the masses. Other services that they have out there that are really interesting that I see is healthcare use cases around image analysis using recognition for early detection of disease, as well as Lex, right? Everyone I'm sure has an Alexa in their home, but really bringing Alexa to life in the hospital. I'm sure everyone saw that that became HIPAA eligible, within the last year, and bringing the ability to have things like drug dosage reminders for the elderly, or connecting to the EMR, not the AWS Elastic MapReduce, but the actual electronic medical record system in the facility so that the physician can actually focus on taking care of the patient, not reading a doctor's notes. And that has been amazingly transformative in some of the more forward-looking healthcare organizations out there. Comprehend Medical, really near and dear to my heart. Connor's going to speak to it today, but the concept being forecasting models of things like drug dosage effects or rehabilitation or text analytics, or, as I just mentioned, unstructured doctor's notes correlation, taking all that unstructured data and being able to build out machine learning models and analytics models to kind of predict, based off of that patient population, what are they at risk of, and really kind of driving up the quality of patient care. I also have on here AWS Translate and Transcribe. Picture the ability to do medical translation and transcription, reducing kind of that manual ICD-10 coding and similar transcription out there, which many of you probably live in that world. I certainly have, but to be able to reduce the time that it takes and, more importantly, error rates, which drive up healthcare costs from an ICD-10 perspective. And so those are some of the use cases that I've seen recently from our customers that are really diving into the AWS ML platform. As I think about Microsoft, I think kind of very similarly, but their focus, at least as the way we see it, is really around kind of that automated machine learning, or the ability to build machine learning models through some user interaction and no code base at all. And so the concept being that it's going to connect into analytics tools out there. The most common one certainly that I've seen in the Microsoft world has been Power BI for that data analysis and that visualization from an AI perspective. And I'm sure that some of you out there have used this, but if you haven't, the cool thing there is that there are an enormous amount of templates, both created by Microsoft and actually out there in the community, that healthcare organizations can select from, and then already built-in integrations into some key health systems that many of you already use today. So you can actually already have that plug-in potentially into your electronic medical record or VNA in some cases when you actually start to leverage that machine learning platform. On the machine learning operations side, they have a tool called ML Ops, picture like lifecycle management for machine learning models. The concept being that it's integrating the model directly into the DevOps or CI/CD pipeline with a deep ability to train and measure and hone the model with native integrations into things like GitHub. And so recent use cases I've seen for this are around medical device error rate testing, ongoing diagnosis of medical conditions out there, and finally predicting the error rates from healthcare coding or ICD-10 coding to improve the accuracy of medical claims. And so Microsoft has done some really amazing work in that space. And then as I think about Google, this was actually, from a personal perspective, the first time that I started building out ML models from a deep learning perspective. And wow, just like the other two, Google has a really, really deep product set when it comes to AI and ML. I would encourage you to take a look at things like AI Hub and the ability to have that one-click artificial intelligence repository for building out machine learning models. But some of the other things that I'd love to talk about on here is the Vision AI, right? And the concept there is that there's a native integration with technologies like TensorFlow, and the deep learning capability allows both, capability on the virtual machine side and the container side that are using active AI learning models that are running all of the time. So it's constantly, concept of deep learning, right? Constantly developing and tuning those models for ongoing improvement. And recent cases that I've seen there is really deep around how can we improve research. So as if they're connected into electronic medical records and feeding some of those machine learning models, the ability to actually gain ongoing insights from that patient population to feed ongoing research on demand all of the time, And one of the neat parts from an ML perspective in general is that the vast majority of these services are what you would consider serverless models. And so in that case, you are only paying for the ongoing runtime of the activities. You're not paying for, the dreaded ongoing operating system in a 24/7 environment. And so the other use case that I would love to mention on here is that Google has celebrated, and I certainly celebrate with them, being able to detect multiple types of skin conditions with simple images and patient history, right? Not even a doctor's visit, not even me going in to ask about it, but really being able to detect that so that they can be identified in an anonymized, compliant way, with the hopes and improvement of really identifying ongoing drug and treatment activity from anonymized data that they have access to. As we move forward, I thought about some of the things that I've seen that have gone wrong from an analytics perspective with some of our organizations that try to really bite off more than they can chew. They think about all of their PHI and try to build in all of their data sets. Let's say it's their Oracle database, their SQL database, their unstructured EMR, their patient health application, their VNA, et cetera. And they really try to do more than that's out there. And kind of what I've seen is that the best way to approach that is focus on a specific use case. One of a very, very close to my heart study that has continued to really drive innovation in the ML space is what Penn has been doing in the area of sepsis, right? And their deep focus was reducing deaths in the hospital as well as readmission rates by understanding failure in surgery and early identification of any kind of blood disease that could lead to sepsis. And so the real amazing thing there is that they focused on not boiling the ocean. They said, okay, we're going to set a goal. That goal is going to be metric-based, and then we're going to send off our data scientists to go chase that goal. And that is where I've seen success in those kind of models. The other one that I would say is don't look at lift and shift as your best approach. I recognize that based off of the organization I work for, that I could certainly be biased here, but know that from experience, I would tell you that lifting and shifting your PHI and your structure into public cloud without even considering some of the native public cloud technologies and tooling out there from the DynamoDBs and other structured and unstructured databases out there that can really scale your data really provides you an opportunity to rethink your data model, and it also just greatly enhances the results that you are going to see. And so from a lift and shift perspective, I would encourage you really to think about once you actually get it in the cloud, which I happen to agree, a lift and shift may be the best opportunity in some use cases, then it's time to think about refactor. Then it's time to think about, even if you don't have the resources to do an application refactor, think about an infrastructure refactor. Maybe that's moving into to container-based environments or platform as a service-based environments or serverless environments. But ultimately, how can you think about your data model being scalable inside of the public cloud is very, very important. And then the final one I would tell you here is really not to forget to train those data models. The whole concept here is that you really want ongoing insights. It's not a one-time set it and forget it kind of model. You want to actually be able to build testing into all of your AI and ML modeling so you can improve results over time. And I mentioned earlier, things like Comprehend Medical are near and dear to my heart. And one of the reasons is because we have seen use cases where organizations are running ongoing ML models leveraging Comprehend Medical to get ongoing doctor's notes to then drive up the percentage of accuracy rate on diagnoses. And so that has been really kind of humbling to witness. As I think about all of these models, then I think about, okay, how can ClearDATA make an impact? How can we make a difference? And one of the key ways that we've done that is we have focused on detecting where PHI lives. We have the privilege, again, of working with hundreds of these organizations And the truth is that most of healthcare out there tends to believe that they know where all of their PHI lives. And the truth is we've seen the opposite. Your PHI doesn't just live in your EMR, and it doesn't just live in your SQL database. The truth is that when we do something called a PHI inventory, or kind of an asset overview of where your PHI lives, it lives all over the place. It lives in your practitioners' desktops, on their workstations, on mobile devices. It lives across sometimes dozens of different medical applications that you're leveraging that probably plug in to your electronic medical record like an Epic or a Cerner. But it really is all over the place. And so there's very few in the field that actually know. And one of the areas where ClearDATA really started to focus was, okay, let's figure out not only how to keep those AI and ML models secure and compliant and private, but let's also figure out where the PHI lives and how does it flow through an application. And so that's where we began as we began kind of our machine learning journey. But to take a step back on how we started doing that, we really focused on how we innovate, or how we help healthcare organizations continue to innovate. And so we work, as I mentioned, with payers, providers, pharmaceutical, and healthcare IT organizations, really anyone who has PHI. And the focus is how can we keep them compliant, but more so the focus is, am I slowing you down? Am I reducing your ability to innovate as you transform into the public cloud, or as you start really trying to gain data insights through some of the machine learning modeling that you're doing? And so ClearDATA really started with a focus on, okay, let's make sure that the healthcare organization can focus on their application from a cloud journey perspective, rather than all of the stuff around it as it relates to security, compliance, and privacy. And so if you look to the upper left, you can see that as healthcare organizations want to move to the cloud, they typically have a sticking point that's probably around how to deal with PHI when leveraging the public cloud. And look, that's our focus, right? We are focused 100% of our time on helping these healthcare organizations leverage PHI to innovate. And that starts with building out automation, as well as building out reference architecture for how to store, process, and transmit PHI, so that when you go to your CISO to move into the public cloud, or if you're already in the public cloud, let's say to leverage a brand new service that's been released last week that is HIPAA eligible, you can really you can be confident that you can leverage that service from a reference architecture and automation perspective, so that you can just focus on using that service and innovate. And that's become very important with some of these machine learning services that have been out for quite some time. But over time, you're starting to see healthcare organizations kind of move from dipping their toe into it to fully adopting them. And that's, I hope, in part because of some of the automation that organizations like ourselves have built. As you think about the automation itself, the whole concept here is to be able to identify those deviations and log them and then remediate them. And so we have built what is known as automated safeguards to be able to do that kind of automated remediation in a quick and efficient way. All of that is then automatically remediated when there's some kind of deviation from that state of compliance, and then finally demonstrated through a dashboard showing a customer in either a downloadable format or a near real-time format, very specifically how compliant am I at the service level, so picture those AWS, Azure, Google services, or at the infrastructure level, picture the operating system with things like patches and backups and all that kind of stuff. And finally, also from a demonstration perspective, as Connor's going to demonstrate in a bit, really some of the insights that we get from a machine learning perspective. So picture the visibility into how PHI flows through a Kubernetes application, just as an example. And so really eliminating that burden of compliance, again, so that you can focus on the application itself. And so let's talk about the visualization of compliance just for a bit. ClearDATA supports lots of regulations out there. Certainly HIPAA's on the top of everyone's list. But look, if we're working with life science organizations in the machine learning space, then we're probably talking about some kind of GXP-like standard, whether it's clinical practices or manufacturing practices. And so we support all of these inside of a portal and that portal shows the customer their ongoing state of compliance. And many of them use this for third-party audits, but also many of them use this for daily snapshots, right? Everyone's probably heard of the culture of compliance or the journey to become a more compliant organization, right? If people are truthful out there, you know that they're probably not at 100%, right? There's probably backup issues or patching issues. Who knows? There could be encryption issues, and certainly ClearDATA's focus is how do we help customers get closer to that 100% journey throughout their life cycle inside of the public cloud. You know, finally, I would tell you that we have a deep history of working with lots of enterprise organizations on solving these problems. And so you can see some of the organizations up here, some organizations in the provider space like Genoa and Dignity Health and USMD and Cleveland Clinic, where we're really helping them accelerate their journey to public cloud, drive automation and ongoing remediation, and really unlocking their ability to leverage data while they're using the public cloud. In the life sciences world, you can see up here Roche and BioReference and Merck and MedNet and others, where we are helping those organizations maintain ongoing GXP and similar compliance standards as they are doing things like anonymization, drug manufacturing, drug studies, clinical trials, these kind of things. And some of them are making an impact in the events of the world right now. So I would encourage you to certainly go out and research those. On the healthcare IT or the healthcare technology side of the business, picture things like mobile device companies or wellness organizations, the app on your phone, and these organizations that are really, they have PHI, probably born in the cloud, sometimes lift and shift and then move to cloud. And we're helping them innovate and really get out of that legacy data center environment, modernize, and then build for scale. We haven't talked about scale a lot today, but that's going to be really, really critical as you think about integration of your data model into machine learning, is how do you actually scale this thing? And then finally, payer organizations. We have the privilege of working with lots of different blues, from Blue Cross Blue Shields to Humana, and really focusing there on things like ongoing engagement, consumer portal capabilities. How do we help healthcare really get a better view into provider costs, provider response, patient ongoing engagement? And so ClearDATA has a deep focus in the security, compliance, and privacy around automating those kind of environments. Now, as we switch to kind of the ML demo portion, I wanted to talk about the problem that Connor and myself and others saw in the market. And you probably saw recent media coverage, around, leading up to what was going to be HIMSS, that we had tackled, one of the big problems in big data analytics, which is, accessing the data while still protecting PHI. And we all know that data in healthcare is incredibly valuable. Certainly I have personally been through, healthcare breaches with my own little children. And so the security and compliance regulations kind of prevent the data from fully being utilized. And we know that there's often requires multiple organizations to kind of work together to make compliance requirements work, which means that it becomes very, very difficult to share identifiable data, right? And so I've had clients sitting on these massive data sets. They want to run ML models against it, but they couldn't because of the restrictions and security necessary to actually protect PHI while they're doing it. And so wanted to introduce and hand off to Connor here in a second, but our focus became around what we recently launched. And the focus really was around data masking, the ability to provide custom and flexible options to help free that data so that you can leverage it from an insight perspective, all the while remaining compliant. And then finally, I will tell you, and with a deep focus on flexibility, while the key, you think about PHI identifiers, there are many out there that Connor's certainly going to talk through, but picture the ability to only mask the ones that are important for your specific study. That kind of puts the data model to work in its best instance. And so, Connor, I'll hand off to you to continue the demo.
Thanks, Matt. So as Matt said, what we've looked at helping folks solve is a way to gain more access to that data to help start building some of these models. So the software that we've released recently is called Locate Mask. It's a data masking service. Locate runs as a software as a service so that you can submit the data from wherever it resides today. As Matt talked about, some of the identifiers that you can choose, knowing from, say, HIPAA identifiers, if we think about just HIPAA for now, think about like names or ages or gender. Some of that information is really valuable when you start building out some of these machine learning models or cloud analytics, but other things aren't. So for example, an identifier would be a social security number, but that is not really important when you think about a machine learning model. They typically don't care about things like social security number, they care about things like ages. So the Locate Mask software is going to allow you to mask the data you need to without removing some of those more valuable items around things like ages or locations or gender. So if we think about some of the use cases that we hear from customers, thinking specifically about what Matt talked about with machine learning models, again, if you think about the more valuable data at scale, thinking about things like the age and the location, but the more sensitive information is the names, the social security numbers, the email addresses. You can easily use Locate Mask as a tool to remove those names and those social security numbers, but leaving that more valuable data. And then you could use that to build a machine learning model that might help predict certain outcomes. So for example, if I walk into an emergency room based on my gender and my age, my history, and my location, that can help determine what my diagnosis might be. It might help the doctors and the nurses with my particular outcome. And that way, that's based on large amounts of data sets, but it doesn't matter so much that it's my name or my social security, but it matters about some of the other requirements. The other thing you can use masking services for is to build out lower risk environments. So things like a development environment where maybe you're going to have your data scientists gain more access without touching the most sensitive data or the highest risk data, or maybe you want to outsource to certain developers. Other use cases here could be you want to create staging environments, maybe a temporary automated staging deployment that will test the next version of your software. And you want to load in a data set that mimics your production, but you don't necessarily want to use a copy of your most sensitive data. You can mask all the potential identifiers, run that data set through the stage environment, and then you would have access to that staging environment, and you can tear it down when you're done. Another use case is things like data review. This could be a way to share data between organizations, again, thinking about removing the most sensitive information, like a name or an age or social security, but leaving those larger, more valuable data sets like ages and locations, genders. The other thing you can do is think about maybe you have an organization that's trying to work with a subsidiary or start up a new incubator program, and you want to give that program access to your data so they can unlock some of the valuable insights in it. You may not want to give them that most sensitive data. So then you can think about how can I remove that data easily and give them that. The other thing you do here is think about when you look into new emerging technologies, you're going to generate lots of some logs or some noise as you analyze the patterns that come through for, say, a container-based application. You could also stream those logs through this program to remove PHI so that you can give the log output to a different kind of tool like a SIM, or even outsource it to a security third-party provider, but again, potentially remove the PHI so it's less risky. So what makes Locate Mask a little different? We talked a little bit at the beginning about the ability to choose the identifiers. So if you think about many tools or even ones that work in databases, it's a little easy to run like a SQL query that simply eliminates names. But where Locate works is because it's backed by natural language processing engines like Amazon's Comprehend Medical, we can actually detect names in the context of particular unstructured data sets. So if you think of in medical terms or medical documentation, there's often a notes field. And that notes field is transcribed by a doctor or nurse and often contains lots of identifying information, but it's not structured in a way that you can simply remove it from a query. So Locate supports both structured and unstructured data and can make a determination if the data is an identifier. And we support multiple file types, so text, CSV, JSON, as well as PDF and images. It's also usage-based, so it depends, there's no software to buy, it's simply a subscription, and depending on how much data you send through, that's how much you're charged. So if you send large data sets or small data sets, it's usage-based, so there is no long-term perpetual license. So we'll take a look at what this looks like. Let me just share my screen. All right. This is the ClearDATA portal where customers can come in and access data masking. It is also available as an API endpoint, so you can stream your data through programmatically. But for today, I'll walk you through what it looks like from through the portal. And if we look at a sample here, we'll take a very simple medical record. It simply has my name, my age, and my email address. If I go and upload that file through the system, I can select, again, which identifiers I want to do. I want to do replacement or redaction. In this case, I'll leave the email address unmasked. So it'll go through the system, it'll process the data, and then return me a file that will get downloaded. The data that's sent into mask is never stored. We don't keep the original data set. And the output, for example, this file, is stored and available for 48 hours. So that way, the data, because there's likely PHI in the output, if you're selectively masking, we don't want to keep it perpetually. So you can see the output here has masked my name, my age, but it left my email address. So if I were to do that again, but this time change the identifiers I want, say I want to leave the age, again, that more valuable information. So we'll go through and mask the data again, and then the system will go through and, again, contextually determine what it found and what it's looking for, give me the file to return, and then we'll be able to see how it compares. So if I download the results, you can see in this case, it has masked my name, but it kept my age, just as we determined which identifiers we want. So again, if you think about how it works for text, it works for PDF. So this is a sample medical record. And then if we run this through and again select particular identifiers, you can see it comes back as a redacted form. So we've in this case redacted names and ages, and it goes through and redacts just with the black cover. And we can do the same thing with images. So today we support JPEG and PNG. You can see in this radiology image we have patient name as well as their age, and we can go through and selectively mask that information as well. So it gets returned the same as a PDF as redacted information. So that's what Locate Mask can help do. So you can send large data sets, small data sets, multiple file formats. We can support direct uploads, again, through the portal or through an API endpoint to make it very easy for anyone who wants to selectively send and track that data. Matt, I'll turn over to you.
Great, thank you, Connor. That is very helpful. And look, I would tell you that this is just the beginning of ClearDATA's journey in ML. I'm sure many of you are experiencing similar, where you're thinking about, wow, look at all these, these amazing technologies from these three public cloud providers. They're not stopping. And so ClearDATA, while we started with the ability to hunt down the PHI. Now it's the ability to really mask the PHI. I would expect that we're going to continue to innovate on ML. Would love to learn more from each of you, how you are planning to leverage machine learning yourselves and figure out ways that we can ultimately help each other, whether it is just conversations like this or deeper architectural reviews. More than happy to leverage our people, our process, and our technology to really help drive better healthcare outcomes, especially with what's going on in the world today. I'm really grateful for everyone's time today. We're going to move into Q&A, and I did see that a question came in. Connor, I will direct this one to you. But the question being, are the locate mask fields customizable for the needs of an organization, as in something that may not be available? And is there a way to unmask something if we need to build something where the data may have been masked previously?
Thanks, Matt. So to answer the first question about the field that may not be available, I did generalize the fields to things like names and ages and 15 identifiers, but we can support some fields beyond that. So for example, we can detect ICD-10 codes and other healthcare specific codes. We can get a full list of identifiers out to you. And if there are ones that are missing from that particular data set, I'd love to hear more about it and what that use case is. So today we have a list of overall roughly 20 fields we can detect, 15 of those being actual HIPAA identifiers. The second question, is there a way to unmask something if you need to build it where the data may have been masked previously? Not today. So today, Locate Mask is simply a one-way masking tool, but we are looking for use cases in ways that we can do the unmasking. I call it tokenization, where it can track unique records and then detect what was masked for that record and potentially re-identify it. So that is something that we are exploring.
Excellent. Well, thank you all for attending today. Would love to continue the conversation. So please reach out to ClearDATA if we can be of any help. And with that, we will end today's webcast. Thank you very much for joining.